Okay, we're going to look at some methods used to graph the inverse of a function. We're going to look at reflecting the graph over the line y equals x, swapping x and y values, graphing from an equation, and then using the draw inverse function on the calculator. And the first method is reflecting the graph over the line y equals x. Now, sometimes it's a little bit harder to do if you have small grids, but one thing that I like about this method here is not really using it to create a graph, but determining if two graphs are inverses of each other. That line, y equals x, is a line of symmetry between your function and the function's inverse. Second way to look at graphing inverses is swapping the x and y values of some of the points on the given function and plot these new points. So you can see right here, I have the point 3.7, and I can switch those x values around to the 0.73, and that will give me a point on my inverse function, and I do that a couple of times, and then I can connect them. And that will give me my new line. And it doesn't work just for lines, it works for any graphs, as we'll see here in a little while. The third method is really just for lines because that is the only thing that we have studied, the only type of graphs that we have studied so far where we are able to look at a graph and determine its equation. So if the graph is a line, then I can write the equation of the line in slope-intercept form, swap the x's and y values to determine the new inverse function, and then graph the new line. Right, so remember that slope-intercept form, y equals mx plus b. I can get the equation of that line from the graph by doing rise over run to determine the slope. In this case, it's 2. And the b is by y-intercept. That's the point where it crosses the y-axis, and here it is 1. Then I can switch my x's and y's and solve for my new y value. And then I can write this in slope-intercept form. Y equals 1/2 x minus 1/2. And then I can use what I know about linear functions to graph this new equation, either doing rise over run for the slope and the y-intercept here, or making a table of values. The third method we're going to look at here just real quick on how to graph an inverse is to use the draw inverse function on your calculator. You'll enter your function into the y equals part of your calculator and then go to program, draw, and then select the draw inverse function. And we are not really going to use that method in class, just so you'll know that it is there if you ever do need it in one of your upper level classes. Now the next part here is that really the method that we're going to be using, going back to that second method, is where I'm just switching the x's and y values. Now I like to start off by making a table of values for my original function here, f of x. So make a table of values, x and y values, and find some points on this graph. Well, here's the point 2, 0. There's the point 3, 1. And 0.62, and this looks like it's 11.3. Maybe not quite there at 11, but it's pretty close. And now I'm going to make a table of values for my inverse function. And I am just going to take the ordered pairs that are in my table up here and then just switch them around. So I've got the 0.02, 1.3, 2.6, and 3.11. Now I'm going to plot these points. 0, 2, 1, 3, 2, 6, and 3, 11, and I'm going to connect them. And that is the graph of my inverse function. And if I were to draw in the line y equals x, I can see that it is going to be a line of symmetry between my given function and the function that is the inverse.